Welcome to 5 challenging SAT algebra questions. Starting off here with question 1, I'll give you a few seconds to pause the video and try it for yourself. I'll begin in 3, 2, 1. Okay, so for this, we have the function f here, gives the temperature in Fahrenheit. That corresponds to a temperature of x kelvins. So this is Fahrenheit, and this is kelvins. If a temperature increases by 9.1 kelvins, remember kelvins is x, how much did the temperature increase in Fahrenheit, which is f of x? Basically, we want to know when x 9.1 is added to x, how much does f of x increase? What we can do with that is actually make a table where we have x and f of x, and we can put an arbitrary number in for x. We can say when x is 10, or when 9.1 is added to x, that'd be 19.1, and then we want to see how much these two values change. Now to find these two values, and the reason we're doing that is because how much did the temperature increase in degrees Fahrenheit here when this is a 9.1 increase? To do that, what we can do is for x in this equation, we can just plug in 10. I'll pull open my Desmos calculator, which is what I would recommend practicing with. X, let's just say x is 10. What we can actually do is we can say x is equal to 10, and then we can put x in here. And then we're negative 273.15 plus 32. Okay, and it looks like that would be equal to, oh sorry, these need rearranged. Or I could just put 10 in there, I suppose. I don't know why that didn't quite work, but anyway, if you put 10 in there, then negative 441.67. Now if we take that same thing, and if we go here, we can copy it, put the settings, and then duplicate. And then if that is instead 19.1, that's what it equals. So to plug that in, we have negative 441.67. And over here we have negative 425.29. And then we want to find how much that changed, or what the increase is, so we can just plug it in here. And we can just do, and that should be 16.38 and 16.38. And that'll be the answer. Moving on to question 2. This is more of a word problem, a little bit more words. I'll give you a few seconds. 3, 2, 1. Okay, so there's a model for the demand Q for a certain product as a linear function, so it's a line, of the selling price P. The demand was 20,000 units and the selling price was 40. The demand was 15,000 when it was 60. And then what is the demand when it's 55? When we have something like this, especially when it's linear, a great way to solve it is, again, with a table. Linear equations and tables work really well together. Here what you can do is we have Q, the demand, P, the selling price, and we know that Q is the demand right here. It was 20,000 when the selling price was 40, and the demand was 15 when the selling price was 60. What is the demand when the selling price is 55? Now for this, something incredibly useful with Desmos is the ability to actually add tables in. So if you go to Desmos, and you click on the plus here, click on table, then you can actually just type in the numbers there. 15,000, 60, and 60. And now nothing really happens, but if we click Add Regression, we can add a linear regression. This works because, there we go. This works because it is a linear function that we're able to do this. And you can see here's the equation in terms of x and y, where x is q and y is p. Now we want to find when y equals $55, because remember p, what is q, or what is x? So what we can do here is just plug for y, plug 55 in, and just type out the equation. 004 x plus 120, and that'll give 16.25 is the value, and 16,250 would be the answer. And it is weird how it gave 16.25, but you can see that the answer here does line up, and that could just be due to us plugging it in and finding the answer with Desmos. If we did it by hand, it might have resulted in the full answer, but you can see and you can select the correct answer. Now, moving on to the next question. We have this here. This here is a graph question. I'll give you a few seconds. 3, 2, 1. Okay. The graph of the linear function here is shown. This is what is shown up there. C and D are positive constants. Which equation could define f of x? Just got cut off there, but you can tell down here. Now this equation is not f of x, it's y equals f of x plus 19. And there's a couple ways we could go about this. What I would recommend is, if you understand functions well enough, then you could know that plus 19 simply means move up 19 on the y-axis. And so this right here would be f of x moved up 19. So to find it, so f of x is down here, but this graph was moved up 19. So to find f of x, you just do this minus 19, which shouldn't be too much of a problem. If we can just visualize this here, we have the graph, and instead of being at 3, it's way down here at negative 16 or so, and then we should have the same slope, because the only thing we did is change where it was. And on a line like this, if we take the form y equals mx plus b, which is how our answers are, they're written with the b term first, which is rather odd, but it's fine. So for this, once again, what we can see is that the b would be negative, it'd be below the x-axis, so this would be negative b, and then we know that m, which is the slope, this is a positive slope, and this is a negative slope. So it's pointing downward, left to right, so it's a negative slope, so negative mx. Now here they use cx and d, but you can see that the form is the same, so if we do y equals negative b minus mx, then negative d minus cx would be the correct answer. I did write y here. This should be f of x, but that's just how the form normally is, so that's why I wrote it like that. But again, this would represent the new graph we created of f of x, and b corresponds to d, c corresponds to n. If you have any questions on any of these, I know I'm going rather fast, feel free to leave any question in the comments. I will get right back to you. I can make another video on something. Just let me know. For question 4 here, I'll give you a few seconds. 3, 2, 1. Okay, we have the graph of this equation here. It is a line in the xy plane where a and k are constants. If the line contains these 2 points, what is the value of k? There's 2 main ways to do this. We can do it algebraically or with Desmos. And the way we do this algebraically is we understand that this is x, this is y, and if we plug this into this equation, then it will work out. So if we know that if we plug this in for x, we get -2 times a, and we have k times -6, so -6k equals 6. And then we also can plug this one in. 0 in for x would make 0 times a 0, so we can just ignore that. And then we can plug -3 in for y, and we're left with -3k equals 6. Divide by -3, k equals -2, which happens to be our answer. Now, that one had a bit of a shortcut because the x was 0. If we were looking for a, we would just plug k in here, and then we just solve for a. But it was just a bit of a shortcut, and they do that sometimes. Another way to solve this, because it might take longer if you weren't given such a one with a shortcut, you could plug these 2 points into Desmos in the table once again. Oh, wrong thing. Table, -2, -6. And then 0, -3. And then expression, since this is linear, we can do this. And we know that if there's 2 points, there's only one possible line that can go through both of them. And so if this line goes through both of them, then this line is equal to this line. And so we know that ax plus ky equals 6 is identical to this equation right here. And right now this isn't working out very well. What we could do is we could add sliders and we could mess around with it until it's right. Or something awesome you can do when you're using regressions is if you replace all equal signs with the tilde, which can be found in the menu under ABC here. And then you also, after each x, click a 1. After each y, click 1. That's because this is x1 and y1, and you want x1 and y1 here. And then it will literally tell you a is 3, k is -2. Just like here. Okay, final question. Line P is defined by 4y plus 8x equals 6. Line R is perpendicular to line P. What is the slope of line R? I'll give you 3, 2, 1. Okay, so line P here is defined by this equation, and line R is perpendicular to line P. And we're looking for the slope of line R. So lines that are perpendicular, if the slope of one line is 14, then the slope of a perpendicular line would be negative. Think of this as 14 over 1, -1 over 14. You simply flip it and add a negative. And perpendicular lines, just as a reminder, would be something, it would look something like this. Just like that, where they intersect at a right angle. Now, we know that line P is here. And then we know that line R is perpendicular. So we need to isolate the slope. And in this form, y equals mx plus b. M is the slope. So what we can do is just move around everything. Divide by 4. And then we're left with -2 x plus 3 over 2. So the slope here of line P is -2. And then we also know that line R is perpendicular, and we want the slope of line R. So we want to find just the conversion we did up here, remove the negative, and then flip it. So that'd be 1/2. And that would be the answer. Thank you all for watching. Hope to see some comments maybe on what I need to do or what would you like to see next time. I can do any hard problems easy problems, medium problems. I can do some more Desmos tricks. I can also go slower on questions. If you'd like, do more questions, just let me know. This is my first one. Again, thank you all for watching. See you next time.